Most welcome to my statistics class. Dear students, hope by the grace of Almighty Allah you are well. This is Muhammad Ashraful Azim, lecturer in statistics, Rajutpura Model College. My dear students, today I'm going to deliver a lecture on measures of central tendency, which is the topic of statistics first paper, and this is chapter 3. And this lecture for the students of class 11 and 12, more specifically for the students of class 11, and this is the third lecture on the chapter. My dear students, in my previous classes I have discussed about the central tendency, measures of central tendency, and different types of measures of central tendency, including the definition, merits, demerits, and I also have discussed which measures is the best and why, and what are the important criterion of a good measure of central tendency. Today, I'm going to discuss about the important properties of arithmetic mean. Dear students, by definition, we know that the arithmetic mean be the sum of all observations is divided by number of observations. So, from the definition, we may conclude that total observation is equal to the product of number of observation and their arithmetic mean. So, the first property of arithmetic mean is that product of arithmetic mean with number of observation is equal to the sum of the observations, which can be expressed such a way that nx bar equal to summation xi. This is for non-classified data, and for classified data, this is capital Nx bar equal to summation fi xi. The second property of arithmetic mean is that the algebraic sum of the deviation of all the observation from arithmetic mean is always 0. That is, summation xi minus x bar equal to 0. This is for non-classified data, and summation fi xi minus x bar equal to 0. This is for classified data. The highly important characteristic of arithmetic mean is that arithmetic mean depends on both origin and scale, and for non-classified data, this is x bar equal to a plus c u bar. Or CD bar, doesn't matter, we may write both way. Here, x bar and u bar be the arithmetic mean, both the old variable and new variable, and a and c be the origin and scale respectively. Then, if there are more than one set of observations, in that moment, if we want to determine the combined mean, then the next property is applied. Let us consider there are a group of observations and number of values are n1, n2, n3 up to nk, and their arithmetic mean be the x1 bar, x2 bar up to xk bar. Then the combined mean will be x bar c equal to n1 x1 bar plus n2 x2 bar plus up to nk xk bar divided by the sum of all observations, that is n1 plus n2 plus up to nk. Now, the next property is that the sum of squares of the deviation of a set of observation is minimum when the deviation are taken about the arithmetic mean. That is, summation xi minus x bar whole square is less than summation xi minus a whole square, where x bar not equal to a, and summation fi xi minus x bar whole square less than summation xi minus a whole square, where x bar not equal to a. The first one for non-classified data and the second one for classified data. Highly important, especially for MCQ, that is the arithmetic mean of the first in nature number is n plus 1 by 2. Then for equal number of observations, the arithmetic mean of the sum of the two variables is equal to the sum of their individual arithmetic mean. And for two non-zero positive values, arithmetic mean is greater or equal geometric mean is greater or equal harmonic mean, and arithmetic mean into harmonic mean equal to geometric mean square. These are the important properties of arithmetic mean. Now I am going to prove an important property, which is arithmetic mean depends on both origin and scale. Since this is a property of arithmetic mean, that is why first of all we'll define the arithmetic mean mathematically. And this is let x1, x2 up to xn be n values of a set of observation, x bar be their arithmetic mean. By definition, we can write arithmetic mean x bar equal to x1 plus x2 plus x3 up to xn divided by total number of observation n. Shortly, it can be expressed such with it x bar equal to summation xi divided by n, and after cross multiplication we get summation xi equal to nx bar. To prove or to compare or to represent a property through origin and scale, we have to consider for single variable, we have to consider a new variable. For double variable, we have to consider two new variables. Since in arithmetic mean there is single variable, that is why we consider a new variable ui, which is xi minus a divided by c, where a and c be the origin and scale respectively. And by cross multiplication, we get xi minus a equal to cui, and by transposing law, xi equal to a plus cui. And taking summation in both sides, we get summation xi equal to na plus c summation ui, and dividing both sides by n, this is summation xi divided by n, which is equal to na divided by n plus c summation ui divided by n. And this is x bar equal to a plus cu bar according to the definition of arithmetic mean. X bar equal to summation xi divided by n, therefore u bar equal to summation ui divided by n. Finally, we get an equation, and this is x bar equal to a plus c u bar. From this equation, we see that x bar and u bar be only two mean of the variable x and u respectively. Rest a and c be the origin and scale. So it indicates that the arithmetic mean depends on both origin and scale. So dear students, today's topic is uh, important properties of arithmetic mean, and I have discussed one important properties and proved the most important property of the arithmetic mean. So no more today. Learn these properties, and I'll discuss the properties in my rest of the properties in my next class. Thank you very much. Allah Hafiz.